Hi everyone, in this video we are going to dive into the encapsulation and abstraction. We are going to handle them together because they are almost the same, but they have a little bit difference from each other. And we are going to see what it is, because it is very important for you to understand these features, because you are going to be asked about this difference in almost every interview. Okay, so let's start with the encapsulation. Encapsulation is an object-oriented programming concept that binds together the data and functions that manipulate the data, and that keeps those from those bots safe from outside the interface and misuse. Okay, data encapsulation led to the important object-oriented concept of data hiding. C++ supports the properties of encapsulation and data hiding through the creation of the user-defined type, which is called classes. Okay, which means that after you type class keyword, you are automatically using the encapsulation. And encapsulation is being supported by the access specifiers, that is public, private, and protected. Okay? We already have written lots of encapsulation examples, but we can see one of them in here too to keep it in fresh. Okay? So the variables length, breadth, and height are private. This means that they can be accessed only by other members of the class and not by any other part of your program. Okay, this is one of the encapsulation is a shift. To make parts of a class public, which means accessible to other parts of your program, you must declare them after the public keyword. Okay, all variables or functions defined after the public specifier are accessible by all other functions in your program. Making one class a friend of another exposes the implementation details and reduces the encapsulation. The ideal is to keep as many of the details of each classes hidden from all other classes as possible. Okay? The common example of encapsulation in real life is capsule. In capsule, all medicine are encapsulated in the side capsule, right? So we are not able to see what is in it. So in conclusion, encapsulation provides abstraction between an object and its clients and protects an object from unwanted access by clients. Okay, so now it's turn for abstraction. Data abstraction refers to providing only essential information to the outside world and hiding their background details. For example, representing the needed information in program without presenting any details. Okay. Data abstraction is a programming and design technique that relies on the separation of interface and implementation. So as the features of this, we can say that the reason to use the abstraction is they hide the details that don't matter from a certain point of view, and identify the details that do matter from a certain point of view, and consider items to be of the same class if they possess those details. Okay, so for example, if I am designing a program to deal with inventory and I would like to be able to find out how many items of a certain type the system has in stock. Okay, from a perspective of the interface system, I don't care if I am getting this information from a database, from a CSV file, a remote repository via a SOAP interface or punch cards. I just care that I can say show method and know that it will return an integer. Okay, the important thing is that I have a show method that showing me the stock, and it will going to be returning an integer. Okay, if I later decide that I want to record that number in some other way, the person designing the interface doesn't need to know, care, or worry about it, as long as he or she still has the show method. Okay, so in this example we have hidden the details of the of how the data is acquired, and decided that anything with a show method is an instance of the same class or a subclass for a certain purposes. Okay, coming back. If I later decide that I want to record that number in some other way, the person designing the interface doesn't need to know, care, or worry about it, as long as he or she still has the show method. Okay, so in this example we have hidden the details of how the data is acquired and decided that anything with a show method is an instance of the same class or a subclass for certain purposes. Okay? Now, if we talk in terms of C++ programming, C++ classes provides great level of data abstraction. They provide sufficient public methods to the outside world to play with the functionality of the object and manipulate object data. For example, state without actually knowing how class has been implemented internally. Okay? So, what are the benefits of using abstraction in your code? Simply, we can say that class internals are protected from inadvertent user level errors, which might corrupt the state of the object. Okay, the class implementation may evolve over time in response to changing requirements or bug reports without requiring change in user level code. Okay, so before the example, basically we can understand the differences between encapsulation and abstraction, and this is very important, so it is important for you to understand it here. Okay, encapsulation is a way to obtain information hiding. So following your example, you don't need to know the internal working of the mobile phone to operate with it. Okay, you have an interface to use the device behavior without knowing implementation details. Okay, abstraction on the other side can be explained as the capability to use the some interface for different objects. Different implementations of the same interface can exist. Details are hidden by encapsulation. Okay, so let's write an example to encapsulation and abstraction both, because the same code can be written for both of them. Okay, so I opened the Visual Studio and we are ready to write our functions and codes. Okay, so as always, I'm going to start typing with including our IOStream library, and it's going to be followed by using namespace std. Okay, so after that we are ready to write our class. Okay, the class keyword is going to be followed by the class name, which is going to be adder here, and in this other class we are going to have a private data member. Okay, and it is going to be integer value, and let's name it total. Okay, and after that we are going to have public member functions and constructors, so that we will be able to reach out and manipulate the totals value. Okay, so first thing is going to creating a constructor. Okay, so I'm typing constructor as comment line here, so that we will be know that. And after that I'm going to type adder, because we are creating constructor and it has to take the same name, take the exact same name with the class. Okay, so adder is going to be our name, and in this adder constructor we are gonna need arguments. Okay, so let's say integer I equals to 0, and in this constructor's body we are going to change the total number with the I. Okay, so what is it doing? This is making that being sure that when we created an object from this adder class, the first thing that is going to be called is the constructor. Okay, so with this constructor we are going to change the totals value with the 0. Okay, so because we assigned this argument's value as 0, and we are going to assign it to the assigning it to the total private member. Okay, so after that we are going to create two member functions. Okay, these are going to be interface to the outside world. Okay, so the first thing is creating the addNum function. Okay, this addNum function is going to take an integer value as an argument. Let's name it number. Okay, so after that in the function body we are going to change the totals value with adding it with the number. Okay, so whenever we make a call to this addNum function, we are going to give it an integer value as an argument, and after that the total is going to be added with this number. Okay, so after this addNum function we are going to create another functions that is calculating the total value. Okay, so I'm going to type integer get total, because we want this to return an integer value to us. Okay, so this is not going to take any argument, and in this function the only functionality that we are going to do is returning the total value. Okay, and after that we are now ready to write our main function. Okay, so I'm typing int main, and in this main function the first thing that we are going to do is get character function and return 0. Okay, so in here we are going to create an object from the other class. Okay, let's create it, and the name is going to be the other. Okay, so be aware of the capitalization so that the other class name is going to be start with the capital A and the object name is not. Okay, so let's add some numbers to this total. Okay, so I'm calling the other objects add num function with the integer value, let's say the 50. Okay, so and after that I'm going to add another value, and it is going to be, let's say, 80, and after that I'm going to call another function called the add num function again, and I'm going to call it with the 10. Okay, so after that we are going to print this to the screen. Okay, so I'm typing cout, and the total number is going to be shown in the screen with the other objects get total function, and end line is following. Okay, so I'm running the code. After compilation it's going to show the resolution to in the screen. Okay, so perfect. It is saying that the total number is 140. Okay, so we use the encapsulation and abstraction in this example. We use this encapsulation and abstraction with the private and the public keywords. Okay, so they helped us to create our interface to the outside of the world, the hidden data to the outside of the world, and so that now we know that how to use private and public and also the protected keywords in the encapsulation and abstraction. Okay, so see you in the next video.